This is homework 6.1. The question is, a normal distribution is informally described as probability distribution that is bell-shaped when graphed. Draw a rough sketch of a curve having bell shape. Bell-shaped curve is like a bell. You start low, go to maximum, come back to low, and it is symmetric. Okay, so the correct answer should be B. That's the normal distribution graph. Remember, normal distribution is same as bell-shaped distribution. Okay. Number 2. Now, what requirements are necessary for my normal probability to be standard normal? Standard normal, if you put standard instead in front of a normal distribution, that means mu is 0, standard deviation equal to 1. This mu is called mu. This is population mean. Remember, we don't use average, instead mean. This is called sigma. Sigma is called population standard deviation. Okay, population STD, standard deviation. Now, if it's standard normal, then mu equals 0. Remember this? Mu equals 0, sigma equals 1. So, mu equals 0, sigma equals 1. Okay. Okay, question number 3. What is Z alpha means? Z alpha question 3. If this is Z alpha, alpha is the area on the right tail. Okay, so this is alpha is area to its right. Okay, area to its right. So if I say, if this is Z.05, this area is 0.05. Entire area is 1. Okay, everything, entire area under curve is equal to 1.0. Question number 4. Find the probability the randomly select passenger has waiting time greater than 1.25. Now, but the question is this: the waiting time between a survey departure schedule and the arrival of a passenger are uniform distribution between 0 and 7. What that means, it's not bell-shaped. Uniform distribution means like a rectangle. Okay, and this area is still 1. Okay, 0 to 7 minutes, so this is 7. So this must be 1/7. That's why that way 7 times 1/7 equals 1. 7 minutes. Now question is, find the probability waiting time is greater than 1.25. So, this is 1, 2, 3, 4, 5, 6, 7. This is 7. 1 and 2 and 3 and 4 and 5 and 6 like this. Greater than 1.25. So 1 is over there. So that point, 1.25. So we're talking about this area. Okay. So the area, entire area is 1, but this red area, so area is, now this length is, now 7 minus 1.25 is 5.75, isn't it? So area is 5.75 times 1 over 7, because height is 1 over 7. So from the calculator, so here, I'm going to clear that, 5.75 times 1 over 7, 1 divided by 7. So you get that area is 0.8214. They want you to round to 3 decimal, so 0.821. That's the area, 0.821. Okay. Okay, question number 5. Question 5. The statistics professor plans classes so carefully that the lengths of her classes are uniformly distributed. Whenever they say uniformly, it is rectangle. Okay, this is called uniform distribution, not normal distribution, but uniform distribution. Uniform means a straight line. And between 48 and 58 minutes. So starting at 48, it doesn't have to start 0, 58. So this length is actually 10 minutes. Okay, because it's 10 minutes, area is equal to 1. That must be 1/10. That area is 1. Now find the probability 50.5 and 51. So if I call this is 50.5 and this is 51. This area is what they're talking about. So this area is 0.5 times 1/10, which is 0.5 times 0.1, which is 0.05. So this is 0.05. Okay. Now, find the area. This is now standard normal distribution. Okay. So this is normal distribution, not uniform. Normal distribution. Okay, and then it is standard normal because mean is 0. Mean is 0. Standard deviation 1. So it's a standard normal distribution. Now find the area shaded. So this is z equals 0. So very slightly right of that, z equals 0.15. So they want you to find all this area. Okay, so now this point is 0. All the way over there is negative. You can think of 999, 999. Over there, all the way is positive 999, 999. Actually, more 9 is okay. Now in the middle is 0. So we like to shade the area. Now to find this area, you use calculator. If you use TIE, now if you click second bars, and then you see normal CDF. the first number is the most left number, negative 9999999, and then the right side is 0.15, and then mu equal 0, sigma equal 1. But these two are optional. Okay, so this is optional. Okay, so if I put normal CDF, the most left number is negative 999,999. You can put more 9, it's okay. Okay, but at least the 6 of them, comma 0.15. That's all you need actually. Then this area of the shade is 0.5596. They like to write full decimal 0.5596. Okay. Now, next one, question number 7. They want you to find this area now. So in the middle is 0. So this number happens to be negative. This number is negative 0.93. They want you to find this area all the way to the end. What did I say? On that side is positive 999,999. So you do normal CDF negative 0.93 and 999,999. So normal CDF, very clear. Second bars, normal CDF, and then negative 0.93, comma 999,999. Then the area, oops, did it again. Oh, I did binomial. No. Second bars, you go to normal. What am I doing here? Normal CDF. Why was that for? Okay, and then negative 0.93, comma 999,999. Then you're going to get 0.8238. So this area is 0.8238. Okay, so 0.8238. Now they want you to find area in between. So here you have symmetric curve. This is negative 0.97. This is 1.29. Okay, so this is a lower limit. This is upper limit. Okay, so what you do here is normal CDF negative 0.97, comma 1.29. That's all you have to do. So second bars again, normal CDF. So negative 0.97, comma 1.29. Okay, so you get 0.73545, full decimal, 0.7355 by rounding. Okay, 0.7355. Okay, now this time go backwards. This is question number 9. What that means, they give you the area. They want you to find, okay, it's in the middle there. They want you to find what is the z-score. This z equals 0 over here. Now this area is given as 0.8686. Okay, so now then what you do here is for the calculator, second bars, you use inverse norm, INVNORM, and is type the area to the left, 0.8686. So go to inverse norm, and then I'm going to clear everything. Second bars, go to inverse norm, and then 0.8686. Then it is 1.1197. Then when you write 2 decimal, I'm going to say 1.12. Okay, so I'm going to put 1.12, 1.12. Okay, all right. Now, next one, almost same idea. Question number 10. Now, they want you to find that z value there. The z value is 0. This area is 0.7357. But we need to find the z. What is this value right here? Is negative. But if this 7357, this area is 0.2643, isn't it? This area is 0.2643. So what you need to do here is you got to put that number. Inverse norm, 0.2643. So inverse norm, second bars, inverse norm, number 3, and you put 0.2643. Then you get negative 0.63. Negative. Okay, so it is negative 0.63. Okay. Now, question number 11. Find the probability that given score is less than negative 1.92. Well, this is 0. So negative 1.92, negative 1.92. Less than, area less than z-score. So this is the picture we should be looking at. So it is D. Okay. Find the probability then. What is the probability is area, you know. Is the SMS area. Now remember, find the area. All the way there is negative 999,999. So we use inverse norm. I mean inverse bar and normal CDF. What is smallest number? Negative 999,999. And then big number is negative 1.92. Okay. That will give the area. What is it? So this area is 0.0274. Okay. So area is round 4 decimal. So I have the 4 decimal, 0.0274. Okay. Now, question number 12. Now, draw a graph, find the area greater than negative 1.87. So it is negative, so there must be somewhere here, negative 1.87. But greater than, all the way. In the middle is 0, at the end is what? 999,999. Okay? So now, same thing. So, normal CDF. Small one is negative 1.87. Large one is 999. 999. That's all you need. Clear that? Second bars, normal CDF. Small one is negative 1.87. Oops. 1 point. Okay. Oops. No. Negative 1.87, comma 999, 999. Then that area. Oh, I do PDF. Sorry about that. It should be normal CDF. Second bars, normal CDF. Okay. And then negative 1.87, comma 999, 999. Okay. If you use this calculator, you have clear second bars. You have the same thing. You have second bars. You have normal CDF. Okay, they asking lower. Lower is negative 1.87. Upper is 999, 999, and sigma mu is 0. Sigma is 1. Just leave it there as a default value. So it is 96925. Okay, 0.96928. Now, they want you to round to how many decimal? Oops. Well, you went to 9, or 10, 11, 12. Okay, we're doing this one. So now negative 1.87 definitely here. Okay. And then area is, I got this one, 4 decimal. So 0.9693. 9693. 0.9693. Okay. That was 12. Now 13. 13 is between, area between 1.5, 2.25. So this is number 13. 1.5 is, middle is 0. So 1.5 is somewhere around here. And then 2.25 is over here. Okay, 1.50, so about that, 1.50 and 2.25. This one. Okay, so normal CDF 1.5, comma 2.25. That's all you need. And then picture definitely fits that one. Okay, so for the calculator, normal CDF, second bars, normal CDF, and then 1.5, comma 2.25. I get this area is 0.05458. They want you to round to, okay, check answer first, and then round 4 decimal, so they have to cut it here. So 0.054. Oh, here we go. What am I doing here? 0.0546. Okay. Now, question 14. Sketch the, okay. Negative 1.74, positive 1.7. This is symmetric then. It is symmetric. This is negative 1.74. This positive 1.74. What is this area? Now, as far as the picture goes, that is that one. Okay, so check answer. Okay, so probability, I mean, it's pretty simple. So second bars, normal CDF, lower is negative 1.74, comma, high is 1.74. Okay, so that area shade is 0.9181. A full decimal, 0.9181. Okay. Now, question 15. Now, what is the P96? We call 96 percentile. That's how you read. This means 96% is below you, 4% is above you. So in other words, if I draw a picture, this point is P96 because this area is 96%, and then this area is 4%. Then this point is called 96th percentile. Okay, so to find that number, all you have to do is put 0.96. So here, second bars, go to inverse norm, and all you have to do is 0.96. That's it. So it is 1.75. Okay, is it two decimal? Well, first of all, we have to shade 0.96. 96% is below you, this guy. Okay. And then P96 is about 1.75. So here, 1.75. Okay. Now, which graph is P20? Question number 16. P20 is 20% is below you, and 80% is above you. That's the meaning of 20 percentile. So if you graph always below 20%, this is 20% below you. This point is called P20. Okay, so as you can see in the picture, there should be like something like B. Okay, and then what is then P20? You gotta put, this is same as 0.2, right? So go to second bar, inverse norm. All you have to do is 0.2. Very simple. So negative 0.841. So this point is P20 is negative 0.8416. Then when you round to two decimal, negative 0.84. So make sure you put negative 0.84. Okay. Now, question 17. How many questions are there? 24. Well, we're almost done. So this is question 17. Sketch the containing lowest 18% and highest 18%. So this is lowest 18%, 0.18. This is highest 18%, also 0.18. So what is this score? What is this score? They're symmetric, so one is plus, one is minus. So all you have to do is, well, we're gonna shade this guy for sure, and then check answer, and then okay, and then the scores, the z-score. So go to calculator. I'm gonna clear everything. So second bars, and then inverse norm, and then you're gonna put 0.18. Then they're gonna give you negative number, negative. So this is negative 0.9153. So that must be positive 0.9153. So in this case, you have to put plus or minus. So plus or minus. Use comma to separate answers needed. Well, you're gonna do, well, we're not gonna do plus minus. We're gonna do one is positive, one is negative. So I'm gonna do 2 decimal. So first one is negative 0.92 and positive 0.92. Let's see. Negative 0.92, comma, just a 0.92. Let's see. Okay. All right, now, question number 18. Find the indicated critical value. Z 0.06 is area in the right tail. Remember that, right tail. So in other words, that point is this area, right tail. This is a right tail. Area is 0.06. So what is this area? This area is a 0.94. Now we'd like to find this one, Z 0.06. To do that, we have to do inverse norm of this guy, 0.94. So you go to, I'm going to clear that. Second bars, inverse norm, 0.94. Okay, you're going to get 1.55. So just put 1.55. Okay. Now fill in the blank. Find the indicated area and curve density in order to then convert it to a percentage and fill the blank. About how many percent of the area is between -1 and 1? I want you to remember 68%. Okay. Well, but you know they want you to decimal, so I'm going to do this. Z is -1 to +1. This is about -1. This is +1. What is this area? Okay, so normal CDF, -1, +1. That's all you need. Okay, so normal CDF, I'm going to clear that. Second bars, normal CDF, you need -1, +1. 6, so this is 0.682689. Then when you write percent in 2 decimal, so this is 68.27%. Okay, when you round, 68.27%, 68.27%. Okay. Now, this is question number 20. Now, significantly high score, which is at least 2 standard deviation above the mean. Okay. So percentage of So what that means here is, if this is 2.0, okay, then anything below that significantly high, negative 2.0, significantly low. This is significantly high if you belong here. This is significantly low. Okay. So what is the percentage of significantly high? What percentage is that? This one. Okay. What is this percentage? 999,999. Over there is negative 999,999. Okay. So because they are symmetric, they are same percent. Okay. So, you do normal CDF 2, 999,999. That will give you this percent. So go to normal CDF, second bars, normal CDF, and then 2, 999,999. Then that right tail area is 0.02275. Okay, 2 decimal percent. So this is 2.28%. Okay, so this is 2.28%. This is also 2.28% because it is symmetric. So I'm going to write there 2.28%. Okay, and the same thing, percentage of bone density that is significantly low is also 2.28%. Okay. Now, percentage of bone density that are not significant in the middle. This is not significant. Well, that is actually 1 minus twice of 2.28%. 1 means, 100%, okay? So 100 minus 2 times 2.28. Oops, no. 100 and one more 0 minus 2 times 2.28, which is 95.44%. So that is, you just have to say 95.44%. Okay, that is 20, and then 21. Question 21. Fill in the continuous random variable has what distribution if the value is spread or evenly over all? Okay, so we're talking about this kind of distribution, remember? What kind of distribution is that? We call uniform distribution. Okay. Right, so this is called uniform distribution. Where is that? Over here. Okay. And then question 21. Which of the following is not the requirement for the density curve? Now, it doesn't have to be. Now, some people I know is tempting to go up. Okay. Question 22. We usually deal with this density curve, normal, but sometimes density curve looks like this. Sometimes density curve looks like this. Okay, so it doesn't have to be centered around 0, but the other requirement has to be met. Okay. Now, question 23. Which of the following does not describe standard normal distribution? Standard normal distribution, let me write again. Standard normal distribution, whenever you hear standard normal, it is symmetric, perfect symmetric, bell shape and symmetric. Okay, and then mu equals 0, sigma equal 1. So let's check. And it is normal distribution, mean 0, that's good. The graphic is symmetric, that's good. The graph is uniform, that is wrong. Okay, it's not uniform. Okay, and question number 24. Okay, here. If you see PZ, this means probability of Z score less than 8. So if I say P, Z is negative 0.8, what that means, it is negative, this is 0, so negative 0.8, Z is less. This is area, okay? If I have PZ less than 1.3, then this is positive, this is 0, is 1.3, so entire area, this is this, okay? So this denotes probability of Z-score less than 8. Well, the first one, what else? Okay, and I think it is the end of it.